Welcome to lesson 3.5. We are going to use zeros to graph polynomial function. Well, in this example, really we're just looking at how to find zeros in different scenarios. When it's in factored form, it's pretty simple. You just set them equal to 0. So one of the zeros is 0, one of the zeros is 4, one of the zeros is -3. Looking at them in order on a well, it's a coordinate plane. You're not seeing the y-axis, but that's where the zeros would be on the x-axis. To see how the function would look, you can actually set it up. So you've got 4 quadrants, right? You've got where x is less than 3. You've got where x is between -3 and 0. You've got where x is between 0 and 4. And you've got where x is greater than 4. So if you substitute a number that is less than -3, it would be negative for all of them. So if you multiply 3 negatives together, you got a negative. Looking at the next section, you can just pick a number that's between -3 and 0. So let's say pick -2. If you substitute -2 in, you get 2 negatives and a positive. When you multiply 2 negatives and a positive together, you get a positive. What that's going to tell you is, well, the zeros are where the function crosses, where the product is negative. So for x is less than -3, the function will be below the x-axis. Where the product is a positive, it will be above. And then it'll be below, and then it'll be above. So then you can get a rough sense of what the function looks like. You don't know how high it goes, what the relative min or max is, but you know where just from that information, just by finding the zeros and then doing this signed interval thing, you can at least get a sense of which side of the x-axis it's on and where it crosses the x-axis. And that'll give you the curve. Remember, one of the things we also talked about is, well, this is a cubic function, right? If you actually were to multiply this out and get it in the standard form, it would be x cubed, would be the first term. There's 2 bends, right? And there's 3 x-intercepts or zeros. That's a function of it being a cubic function. You're going to have the same number of zeros as the degree of the function, and you're going to have one less turn than you would whatever the value of n is. So if it was 4th degree, you'd have 3 turns. 5th degree, you'd have 4 turns, and so on. All right. We have 2 of these to try on your own. So why don't you pause here and give it a try, and then come back and check it out. So I first factored a 4x as a GCF out, and I was left with a quadratic x squared plus x minus 6, and that factored in x plus 3 and x minus 2. Now I have my zeros. They're at 0, -3, and 2. So I plotted them there. I did the chart with the 4 intervals. I figured out what the sign would be for a number in that interval for each of the factors, and then got the product. So this is really the part that's going to tell you whether it's above or below. So first interval is below, then it's above, then it's below, then it's above. And then I drew my curve in that way through those zeros. All right, let's take a look at the next one. So same deal here. You're going to factor first, get the zeros, then plot the zeros and try to draw the curve. So why don't you pause, give it a try, and then come back and check it out. So here when you factor the difference of squares, you get x squared minus 9 times x squared plus 9. Nothing else you can do with the x squared plus 9. The x squared minus 9 can factor in the x plus 3 and x minus 3. So you only get 2 real zeros, -3 and +3. If you were to solve the quadratic x squared plus 9, you would get imaginary numbers, which is not going to help you when we're graphing and finding zeros. So there are no zeros you're going to get from that part. So there's only 2 zeros, -3 and 3. So you only have the 3 intervals, less than -3, between -3 and +3, and then greater than +3. check out the interval, like the signs in those intervals, you get plus, minus, plus. So above, below, above. The reality is it's going to bend again, actually twice down here. But we don't have that information given what we're trying to do here. So all you know is it does curve. It is above, below, and then above the 2 zeros that we have. So that's what you can draw at this point. All right. Let's move on to example 2.